again. Here I am back, and we're going to do 6.5a. I chose to break up the area under a curve and between the curves into two separate lessons so that you can maybe take time to understand and make sure you know what the critical points are a little easier. So we're going to do right now 6.5a, area under a curve to the x-axis. So the first thing is going to be you're going to have a curve. And you're going to have a distance from A to B that you're going to measure it or try to figure out the area in between there. So first of all, you need to know some properties of area. Number one, it's non-negative. Area is always greater than or equal to 0. So for instance, if you get a negative answer, you can't have negative area. If you did a rectangle and you did 6 times 8, you'd get 48. You would not get negative 48. So therefore, you need to make sure you absolute value it if you happen to get a negative answer. It's going to happen. I'll explain in a while. Number two, it's the additive properties. So let's say you have two different areas, one here and one over here. You can add the two areas and you can get a total area. So it's an additive probably. Also, you need to make sure that f, or the function, is continuous over the interval of a to b. And the derivative can be found. So you have to make sure the derivative can be found. So therefore, we're going to try this area under a graph of the graph formula from a to b is the integral from a to b of f of x dx. So you're just going to integrate, just like a definite integral, from a to b of f of x dx. That's going to be your formula or your equation. So we're going to try that right here on example 1. Find the area under the graph of f of x equals x squared. Well, we all know x squared is a parabola from 0 to x equals 1. So from 0 to 1. So I wrote 3 steps down here. Number 1, I highly suggest you draw a picture. Okay, so I drew my picture of my pink parabola there. Number 2, I shaded the area that it suggested that I find. Remember, I only needed to find it from 0 to 1, and it's from the curve to the x-axis. So I shaded that in little green there. That's the area I'm going to find. Step 3, integrate from a to b. So I put it here for my integral from 0 to 1 of x squared dx. So that's my step 3. So I highly make sure you draw a picture, shade it, show where the shaded areas are, and then find where you're doing it. And this time it was given 0 to 1. So I integrate x squared. I get x cubed over 3 from 0 to 1. I place in my numbers, just like we did on definite integrals. 1 cubed over 3 minus 0 cubed over 3. 1 cubed over 3 is 1/3 minus 0 is 1/3 units squared. By the way, all area answers will be units squared, or if they give you a dimension, make sure you square the label. So that's really what the whole process is. So it's nothing less than the definite integral, finding it from two numbers that they give you. Well, they don't always give it to you. This one I did. But I said, what if the area is split? So find the area enclosed by f of x equals x cubed. Well, you all know that that's a little swish there going through 0, 0, 1, 1, or 1, 1, and negative 1, negative 1. So there's my x cubed, and I want it from x equals negative 1 to x equals 1/2. I do not want all the way to 1. So I need from negative 1 to that 0, and from 0 to that half. So I drew my picture. I suppose I should pause, let you draw the picture. Make sure you space it out enough so you can see where you're actually shading. So from negative 1 to 0, it broke, and then from 0 to 1/2, there is another one. So that means I have two areas. Remember at the very beginning, you can add two areas together? This is where it was talking about. So I'm going to find the area between negative 1 and 1, or negative 1 and 0, because whenever it crosses the x-axis, you have to change that to another critical point or one of your a and b's of x cubed, and I'm going to add it to from 0 to 1/2 of x cubed. So I have two integrals that I'm going to do. So I integrate x cubed, and I get x to the 4th over 4 from negative 1 to 0. Well, I do the 0 first. Well, that's 0 to the 4th over 4 minus, do the negative 1 to the 4th over 4. Well, 0 to the 4th over 4 is 0. Negative 1 to the 4th is positive 1, 1/4. But this is a subtraction sign because it was f of b minus f of a. So that's a negative 1/4. But what can you have? You can't have negative answer. So note, a negative answer, area is always positive. So you absolute value any of the areas under the axis to make them positive. You can also do a negative of a negative, but typically it's easier for you to understand if you just absolute value. So when I bring this down to add, I brought down 1/4, positive 1/4. Don't forget, you had a second one though. So we had to do it again. We had x to the 4th over 4 from 1/2 to 0. 1/2 to the 4th over 4 minus 0 to the 4th over 4. Well, that part's easy. That's 0. But 1/2 to the 4th is going to be 1/16 over 4. And I put it over 4 over 1. I reciprocated that denominator to times it by 1/4. 1/16 times 1/4 is 1/64. So the area of that little tiny from 0 to 1/2 is 1/64. And I have to add it to my original 1/4. Then to add fractions, you have to have a common denominator. So I take this times 16 and that times 16. I get 16 over 64 plus 1 over 64 is 17 over 64 units squared. I'll give you a minute to look at that. Again, draw a picture, show the shading, figure out what your criticals are going to be, and integrate. You can have two parts. All right, I'm going to show you one more example. That's example 3. And in example 3, we're going to do the integral, find the area enclosed of x squared over 4. Let's see if I'm on your screen here. Well, son of a gun. I'll just have to pray that I am. And it's x squared over minus 4. So this is x squared minus 4. Well, most of us understand and remember that means that that's going to be the vertex is going to be at 0, -4. Okay, so I went by 2's on my little graph. I draw. And then it has to go from 0 to 4. But at 2, it crossed the x-axis. Now, most of you would remember or understand that. Also, it would have crossed at -2, but it didn't ask me to do anything on the negative side. So if you would have factored x squared minus 4, you would have gotten x plus 2 and x minus 2. Those are going to give you your points where you're going to cross the x-axis. So 2 is where I crossed, but I needed to do from 0 to 2 and then from 2 to 4. So I have to integrate from 0 to 2 of x squared minus 4 and from 2 to 4 of x squared minus 4. So this one took a little bit more math. The integral of x squared, I suppose I need to give you a chance to write that down. Sorry. All right, the integral of x squared minus 4 is going to be x cubed over 3 minus 4x from 0 to 2. Same thing over here, x cubed over 3 minus 4x from 2 to 4. Let's start with this one first. So I put in my 2 to start with. I have 2 cubed over 3 minus 4 times 2 minus the quantity. Don't forget to do a quantity when you have adding and subtracting of different terms in there. 0 cubed over 3 minus 0 times 4, which just happens to be 0, which is fine. But you still have to do good math here. So I have 8/3. 2 cubed over 3 was 8/3. Minus 4 times 2 is 8 over 1. I have to have a common denominator. So that was 3. So I multiply that times 3, and I get 8 minus 24, which gives me a negative 16/3. But what do you always have? Can you have a negative area? No. So before you add it together, you have to absolute value it. Before you add it together to get 16/3. All right, I'm going to go up to the blue over here for the second half. I already have it integrated, so I just put 4 in. So I have 4 cubed over 3 minus 4 times 4 minus the quantity of 2 cubed over 3 minus 4 times 2. 4 cubed over 3 was 64 over 3. 4 times 4 is 16 over 1. I know I have to have a common denominator, so I multiplied it by 3, and 3 times 16 is 48. Now, 64 minus 48 is going to be 16/3. But check here. Now, I already got the answer over there was negative 16/3. So yes, the answer here is negative 16/3. Note, you do not absolute value it there. You're still in your equation. So you do the math of your equation. So that inside that green was negative 16/3, but a negative of a negative made it plus 16/3. So you add the two together and you get 32/3. Now that's 32/3 for this half of the curve, or for that from 4 up there, that top half. The other one was 16/3. Remember, I still had these two, so I have to add these two together. 16/3 plus 32/3 is going to be 48/3, which comes out to a nice 16 units squared. So you have to be careful. If there's more than one part, you have to add them, but make sure you do all the math before you absolute value it. Notice all the math, and then I didn't even have to absolute value it. Note, the only ones that come out negative are the ones that are below the axis. They will come out negative. Anything above the axis will have a positive answer. If it doesn't, you didn't do something correct. All right, I changed up the assignment just a tad. We're going to split 6.5. So if this is 6.5a, you get to do a whopping 3 problems. 1, 6, and 9. I added number 6. So that's all that's different. So I split 6.5 assignment to 6.5a and 6.5b. So that's all you have to do. I'll let you sit there and stare at that for a minute. And I think I'm going to have to use my phone to turn this off because it decided to go off my watch. All right, thank you. I'm going to put this down and switch this.